Welcome to the deep dive. Today, we're really jumping headfirst into the world of open source AI.
Right.
Specifically, we're looking at how these, powerful vision models are changing, something like optical character recognition, OCR.
Yeah. Which sounds standard, but we're digging deeper, right?
Exactly. Not just reading text. We're focusing on a pretty tough task,
Yeah.
extracting structured data. Think JSON from documents.
Mm-hmm. And we've got a great guide for this, an evaluation from Omni AI. They've basically put some of the top open source vision language models, the VLMs, through their cases.
Okay.
Specifically on this JSON challenge, how accurately can they pull info out and, crucially, format it correctly?
Right. So our mission here is to unpack what they found.
Yeah.
We want to see which of these, cutting-edge open source models are actually leading the pack.
Yeah, and what does it all mean for anyone working with documents day to day?
And explore some results that were honestly pretty surprising when I first read them.
Oh, definitely. And it's such a good time for this kind of test, isn't it? The whole open source scene has just been buzzing. So many new VLMs.
Yeah, totally. Just in the last few months, new models, big updates,
Yeah.
models getting much better vision capabilities.
The article mentions the key ones they tested, right?
Yeah, they looked at Qwen 2.5 VL, the new Gemma 3, DeepSeek V3. Well, not DeepSeek V3, but some others.
And the recent Llama 4 iterations, like Maverick and Scout.
Yep, those two.
So,
And importantly, the new Mistral Okram model.
the one named specifically for OCR, that sets up an interesting comparison.
It does.
And it's worth flagging the scope here, like you mentioned. They focused only on open source VLMs with native vision support built in.
Right.
So models like DeepSeek V3, maybe some Llama versions that don't have that integrated vision piece, yet they weren't part of this particular benchmark.
Okay, makes sense.
And they also deliberately set aside the more traditional OCR tools, like paddle OCR or Dockling, for this comparison anyway, saving those for later maybe.
Gotcha. Okay, so let's get into the benchmark itself, the nitty-gritty. They ran 1,000 different documents through these models.
1,000. Wow.
Yeah, and the core task, as we said, JSON extraction accuracy. So basically, an image of a document goes in. The VLM chews on it, and the output is supposed to be a perfectly formed JSON object with specific info pulled from the doc.
And judging that output, that's actually quite tricky, isn't it? How do you consistently say, yes, this is correct, or no, this is wrong?
That's what I found fascinating. Their method for deciding correctness, they actually used GPT-4o as the judge.
Okay, using an AI to judge an AI. Interesting. How did that work?
So they gave GPT-4o the raw text output from the VLM being tested,
Right.
along with the expected JSON schema, like
Yeah.
the structure it should follow. And they used GPT-4o's special structured extraction mode.
The one that forces it to stick to a format.
Exactly. Then they compared what GPT-4o extracted from the VLM's output against the actual ground truth, the perfect JSON answer.
That's clever. So GPT-4o is acting less like a reader and more like a schema-aware parser and validator.
Precisely. They mentioned trying others like Claude 3.5 Sonnet, Gemini 2.0 Flash, but GPT-4o was apparently the most reliable at sticking to that JSON schema, which was critical here.
Makes sense. Did they test the judge itself? Like, how good is GPT-4o at this, ideally?
They did. They set a baseline by feeding GPT-4o the perfect text from the ground truth plus the schema.
Okay.
And even then, GPT-4o only hit around 99% accuracy.
So, not perfect, but pretty darn close. That gives them confidence in the judging process while acknowledging, a tiny potential error margin in the evaluation itself.
Exactly. All right, enough setup. Let's talk results. Because reading through, a couple of things really jumped out.
Absolutely. I think the clearest headline, if you had to pick one winner among the open source contenders in this test,
Yeah.
it was the Qwen 2.5 VL family, both the big one, the 72B parameter model, and its smaller sibling, the 32B.
Okay, Qwen, how did they actually score? What were the numbers?
Both of them landed right around 75% extraction accuracy.
75%. Okay,
Yeah.
that sounds respectable. But what makes that number stand out?
Well, here's where it gets really interesting. Both those Qwen models, they scored higher than Mistral Ochre.
Wait, hang on. Mistral Oak, that's the one specifically trained for OCR tasks, right?
That's the one. Qwen is more of a general-purpose vision language model. It does lots of things with images and text.
So let me get this straight. A generalist VLM beat a specialist OCR model on this specific JSON extraction test.
Yep, that's what the benchmark showed.
Wow. Okay. That feels significant. Why?
Yeah.
Any theories on why that might happen?
It is significant, and I think It probably speaks to what this task actually requires. JSON extraction isn't just about reading characters perfectly.
Right, there's structure involved.
Exactly. It's about understanding the layout, the structure, the sort of relationships between different bits of text on the page to pull the right value for the right key in that JSON schema.
Okay, so the broader understanding helps.
Potentially, yeah. A generalist VLM like Qwen, with maybe a broader visual and language grasp, might just be better at understanding that overall document context needed for accurate structured extraction.
Even if, say, Mistral Ochre might be better at pure character recognition on a really noisy, difficult page.
Possibly. For context, Mistral Ochre came in at 72.2%, so Qwen's roughly 75% wasn't a huge lead, but it was a definite measurable lead in this benchmark.
Fascinating. Okay, let's switch gears. What about Gemma 3? The article called out its performance as surprising, but maybe not in a good way.
Yes, Gemma 3, the 27B model specifically, it landed, well, significantly lower than you might expect, just 42.9% accuracy.
Whoa, okay, 42.9% compared to 75% for Qwen and 72% for Mistral Ochre. That's a huge difference. Did they figure out why it struggled so much? Was there one specific thing it kept failing at?
It seems not. They actually mentioned spending extra time digging into Gemma 3's outputs precisely because the result was so much lower than they anticipated.
Man.
And what they found wasn't like one single consistent error. It was more a mix of the usual VLM failure modes, such as
Making things up, hallucinations, missing information that was clearly right there in the document, or just, mixing up different bits of text.
So typical errors, but just more of them.
Apparently so. They even included an example in the article. The output looked like OK JSON at first glance.
Right.
But when you actually checked it against the original document image, it was just riddled with mistakes, made up values, missing key data points entirely.
Huh. So even though Gemma's architecture might be similar to other models that do well elsewhere, on this specific test-structured extraction from documents, it really stumbled.
Correct. It just highlight the, headline comparisons or just looking at model architecture. It isn't the whole story.
Yeah, the training data, the fine-tuning for specific tasks must make a huge difference.
Absolutely. How the vision and language parts actually work together, it all matters. And Gemma 3's performance here suggests it just wasn't as robust for this particular job as the others they tested. Okay. Shifting slightly again, the article also talked about the practical side of things, actually running these benchmarks with open source models versus just using, say, a big cloud provider's API.
Oh, yeah.
Sounds like just getting the infrastructure working was its own challenge.
It absolutely was. I mean, think about it. Running 1,000 documents through multiple large VLMs, that takes serious compute power.
Right.
And while the models themselves are open, getting access to them and scaling them up efficiently for a big benchmark, it's not always simple. They looked at both hosted services and, doing it yourself.
What did they find with the hosted options? Were they easy to use?
It was a mixed bag. For getting early access to the newest models like Gemma 3 when it first dropped or the 32B Qwen, services like OpenRouter were useful.
Yeah.
But they could have pretty tight rate limits, which makes running a big batch like 1,000 documents slow or difficult. Together.ai was mentioned as being good for scalable inference for models they already had, like Llama 3.2. But again, maybe a bit of a lag getting the absolute newest releases up sometimes.
Right. The bleeding edge is hard to keep up with.
And they had this funny note about Google AI Studio. It had Gemma 3 available, but apparently in their testing, it didn't seem to recognize it as a vision model, which, given Gemma comes from Google, was quite surprising.
That is weird. Okay, and for Qwen, 2.5 VL, the top performer, where did they run that?
They started testing it on OpenRouter, I think, but needed more capacity for the full run, so they ended up using DashScope.
DashScope?
Yeah, it's Alibaba Cloud's model platform. Makes sense, since Qwen originates from Alibaba.
Ah, okay. And what about just downloading the weights and running the models yourself? Self-hosting?
Definitely an option. They mentioned platforms like Hugging Face Inference Endpoints, Friendly, AWS SageMaker. You can do it.
Sounds like there's a but coming.
But they described the setup process for each of those as, and I quote, a bit of a pain, especially compared to using more mature, traditional cloud services.
Right. Less plug and play.
Exactly. Which is why, for actually executing the bulk of the benchmark smoothly, they leaned on those hosted providers we mentioned, OpenRouter, DashScope, Together.ai.
So the takeaway there is, even if the model code is open, the practical stuff, deployment, scaling, getting reliable performance for real work, That's still a major factor to consider.
Absolutely. It highlights that the whole ecosystem, the hosting landscape, it's fragmented and it's evolving just as fast as the models themselves.
Okay, so let's try and wrap this all up. Thinking about you, our listener, what are the key things to take away from this deep dive?
I think the main point is these open source VLMs, they're advancing incredibly quickly. They're becoming genuinely capable at complex document tasks like this JSON extraction challenge.
Yeah, they're not just toys anymore.
Not at all. Models like Qwen are showing really impressive performance, and the fact that in this specific test, a generalist VLM could actually outperform a model specifically tuned for OCR, that's a big deal for structured tasks.
But it's important to remember it wasn't like a clean sweep for all open source models, right?
Definitely not. The Gemma 3 result really underscores that.
Oh, yeah.
Huge variability between models. You can't just assume all new VLMs will excel at everything.
And those practical hurdles we just talked about, actually running and scaling these things efficiently, that's still a real consideration compared to just hitting a mature API endpoint.
Right. The whole landscape is just incredibly dynamic. New models pop up all the time. They push the boundaries. And benchmarks like this Omni AI one, they're vital. They give us a snapshot, a data point of where things stand right now.
And understanding these evaluations, it really helps cut through the hype, doesn't it?
Totally.
It gives you actual data on what's possible today with open source tools. That's kind of a shortcut to staying informed in a field that moves, frankly, ridiculously fast.
If you're looking into open source options for document processing, maybe trying to figure out what could work for you, these results give you a really solid starting point. Which models are worth investigating further?
And one of the great things about open source here is the transparency, right?
Oh, absolutely. The article explicitly mentions this.
Yeah.
The data set they used, the methods for the benchmark, it's all open source.
Which means if you're curious, you can actually go and dig in yourself.
Exactly. You can look at the raw data, the document samples they used, check out the benchmark code repository on places like Hugging Face or GitHub.
That level of openness is just invaluable, I think.
It really is. It allows others to verify the results, maybe build on them, run their own tests. That's how the community pushes things forward.
Okay, so here's a final thought to leave you with, something to chew on maybe.
Okay.
We saw this generalist VLM, Qwen, outperform the specialist Mistral OCR on the specific JSON extraction task. What does that suggest about where AI is heading? Are we moving towards a future where these broad generalist models eventually just dominate most tasks, even really specialized ones like document understanding? Or is there always going to be a critical need for those highly specialized, fine-tuned architectures?
That's a really fundamental question, isn't it, about how AI capabilities are going to evolve and sort of how they'll be best deployed in the real world over the next few years. Generalist power versus specialist precision.
Exactly. Food for thought.
Definitely.
Well, thank you for joining us for this deep dive into the sometimes surprising world of open source VLM performance on OCR and structured data.
Been fascinating to discuss.